Can you hear me? Okay, awesome. Yeah, so last session of the day, whew, I think they put me on as like some entertainment. I'm not quite Sonny levels of entertaining, but I'll at least like try to keep you happy in the last session. Hopefully you've gotten a deep breath after all the IV stuff that you've learned. So we're going to talk about facades today. And facades can be a little controversial. You might have heard different people talking about them whizzing around the community. Some people love facades. Frosty, who isn't here today for some reason, but Aaron Frost, who runs NgConf, he loves facades. He thinks it's a pain to have to inject the store into components. Some people, like a certain someone sitting in the front row who just gave a talk, are a little bit less keen on facades, a little more skeptical on them. And then I'm sure there's a chunk of you out there who are just sitting there thinking, like, what the heck is a facade? What is this word that you keep saying? So we're going to talk about that. I'm going to go through and explain what facades are, and we're going to look at the pros and cons of facades and whether you should use them, and we'll cover a lot of ground. So I'm Sam Julien, as Shmala said. You can follow me on Twitter at Sam Julien. I'm a developer advocate engineer, which is a fancy word for developer relations at Auth0. I'm a GDE and an Angular collaborator. I created upgradingangularjs.com. I'm also an author at thinkster.io. I'm about to come out with a course on Gatsby, the static site generator that uses React. React and GraphQL. So I'm going to be coming out with that shortly. So I mentioned Auth0. We provide an authentication and authorization service for developers. It's simple but extensible, and it's got a real focus on the developer experience. I also live on a small organic farm, so these are my 19 chickens. And these are my 2 llamas, Michelle and Barry Olama. So, that's Barry over there, and then that's Michelle. It's not showing. Oh, well. But Barry's on the left. And so if you follow me on Twitter, you'll get a lot of chicken and llama content on there. Follow me for the chicken and llama content. That's the good stuff. So first and foremost, what the heck is a facade? Like, what do I even mean when I talk about a facade? Well, this is a very famous facade in your neck of the woods, Buckingham Palace. There's another famous facade in your area. This is 2223 Linster Gardens. The building on the left is real, and the building on the right is fake. So if you go around to the other side, this is the back of the one that was on the right. It's actually railroad tracks running through it. So this is a type of facade, but this is sort of a facade in the way that we think of Instagram being a facade, right? Like, it's like, people post these like beautiful pictures. Thank you. Thank you. I wish I had created this picture, but yeah. So this is sort of a type of facade, and we use it in sort of like common parlance, right? It hides away the messy things, and that's sort of what we mean. But when we talk about facades in code, we kind of more mean your relationship with your car. So when you get into your car and you use your gear shift and your drive pedals, you don't have to think at all about like combustion and how the engine works and all the details of how the car goes forward. The car abstracts away all those details for you. So the car is sort of like acting like a facade for accelerating a vehicle. And that's sort of more what we mean when we talk about facades in code. So with code, usually when we're talking about facades, we're using the facade pattern. And this is a pattern that was popularized in the book Design Patterns, which is sometimes referred to as the Gang of Four. So what is the facade pattern? What does that mean? Let's say that I have a client, and the client has to call 3 different services to go get some data, right? So we've got this class here. It's got a function called do something, and inside of that function, it's got to go call service A, and then call service B, and then call service C. And that's fine, that's great, you know, no problem there. But then your boss comes along, and your boss is like, you know, I think actually instead of service C, we really need to use service D. So you're like, okay, fine, did that, no problem. That's okay. But then a little bit later, it turns out that you need to replicate that exact same behavior in another part of the application. So now you have to keep track of this in 2 different places. And your boss comes along and is like, actually, you know what? It's not service D that we need. It's service E. So you're like, okay, fine. I change it there. And then you're like, oh, dang it. I forgot. I have to go change it over here, too. And then a few months later, it turns out that there's another place that you have to replicate this same behavior, and on and on and on. and you just start losing track of where you're supposed to maintain this behavior. So this is where facades are actually really useful. So with facades, instead of having the client worry about service A, B, and C, we can insert this layer of abstraction between the client and the services. And this way, the client doesn't actually have to know anything about what is going on under the covers. So in our little general example here, we've got this client, and we can actually take this code and move it into its own class called a facade. And this facade now has a function called getEverything, and getEverything is containing all of those extra details of how the data is getting retrieved. And then in the client, we can actually just call the facade, call the getEverything method on the facade. So this is really nice, because then if we need to make some sort of changes, like if we need to change service C over to service D, we just do it in the facade, and we don't have to worry about it anywhere else. Back in the client, we don't have to change anything, and if we're doing that same behavior multiple times, we don't have to change anything anywhere else. So this is great. What about facades in NgRx? What are we talking about there? So to explore that, I have good news for you. Mike made you all open source developers. Now you're all working for CERN, the Council for Nuclear Research in Switzerland. You're all now engineers for the Large Hadron Collider. Congratulations. That's your going away present from Angular Connect. And if you don't know what the Large Hadron Collider is, it's a particle accelerator that has these two beams of light, and they go super fast, almost at the speed of light, and collide. And the reason we're doing that is we're trying to find the Higgs boson particle. Now, the way this works is that there's this ring of magnets along that are cooled down to negative 271 degrees Celsius, colder than space, and that's how the particle beams are able to go so fast. So we've been instructed to re-architect the software that runs the Large Hadron Collider. And as you might imagine, it's extremely sophisticated software. It looks like this. This is actually, if you go to the Large Hadron Collider website, this is actually the dashboard that you can see to see the status of the Large Hadron Collider. It's called Vistars. This is another dashboard that's on the Large Hadron Collider. So you can imagine this is a large, complex, event-driven application, right? You have to know the status of the beams, the temperature of the magnets, the status of the collider, all kinds of things. And when I think of large, complex, and event-driven, I think of NgRx. So we're going to use NgRx. You've probably seen this diagram. This is a really creaky floor. I don't know if you can hear it out there. But you've probably seen this diagram. Me and Mike gave a talk at NG Vikings that used this same diagram, and Mike uses it in pretty much every talk he gives about NgRx. I tried to get him to use this diagram in his Ivy talk, and for some reason he wouldn't do it. But the NgRx architecture is famous for this indirection, where the view layer doesn't have to know anything about how state is changing. So let's think through how we might architect this application with NgRx. So first, let's think about changing state with actions. So with changing state, the components dispatch these actions through the store, and the actions travel through the effects and the reducers to change state. So for the Large Hadron Collider, we might have a whole host of actions. Just a few that we might think of are maybe the Beam1 status, the Beam2 status, the temperature of the magnets, and maybe finding the Higgs boson particle at some point. That would be ideal, right? And the nice thing about actions is if we use them correctly, we should be able to go back to the log and see exactly where all of these actions came from. So then in our code, we could use the new action creators in NgRx 8, and we could create an action like start beam1. Perfect. So what about reading state? Well, we read state through selectors. So the components can use a selector to read state from the store. So how would we do that in the Large Hadron Collider? We'd probably have a lot of different statuses to keep track of. So we might create selectors for the Beam1 status, the Beam2 status, the magnet temperature, the collider status, a lot of things that correspond to the actions that we're doing. And then in our code, we'd do things like store.select, and we'd have select Beam1 status. So let's look at our Beam1 component here. So in Beam1, we've got our constructor where we inject the store. We've got a turn-on function, and in this turn-on function, we dispatch an action to start Beam1. And then we have a selector for our Beam1 status. So this is all pretty standard, pretty straightforward NgRx. But some people are not super happy with this. Some people don't really like the store, the component to know about the store. OK, fine. Where could we use facades to help this problem if we don't want the component to know about the store? We can actually do something similar with the facade pattern. So we've got our NgRx architecture here. So what we'll want to do is we'll want to insert a layer of abstraction between the store and the components. And that will be our facade. So what does this look like? Well, if we go back to our Beam1 component, we can extract a lot of this code into another class. This class is just a regular injectable. It's basically a service called Beam1 Facade. And we'll use our store here in the constructor. We'll move our turn-on method over to the facade, and we'll move our selector over to the facade. And now, when we go back to our component, we're going to use the facade instead of the store. So we'll have a constructor where we inject the facade. We'll call the facade's turn-on method, and we'll use the Beam1 status from the facade instead of the selector. We should have a drinking game or something where every time I say facade. Not necessarily alcohol, just anything. So the nice thing about this is that we can abstract away the implementation details of like the turn-on method. So in the turn-on method, maybe we need to change the action that we need to use, so we can just make that change in the facade, and then we don't have to make that change anywhere else. And so I know now you're thinking like, OK, this is awesome. Now the components don't need to know anything about the store. Facades are fantastic. This is everything I've ever wanted, and I'm going to go out and use it right now. But it's unfortunately not that simple. There's a few things that we need to consider a little bit more carefully, and I want us to reason through this architecture decision here. So remember, one of the things that we said was the magic of the facade is that when we need to replicate code and use it elsewhere, we don't have to make those implementation details available everywhere. But if we think about NgRx, what's one of the staples of good action hygiene? It's that we don't reuse actions. Actions are meant to be unique. So if we go back and look at the actions we've decided to use, we have this namespace here, Beam1, Beam2, Magnets Collider. And the idea of this is that someone going through the log, say years down the road, there's some bug that comes up, somebody can actually go through and know exactly where everything is happening. And that's one of the many reasons that we make actions unique. So you might be thinking, I don't think this is going to happen. So let's think through an example here. Let's say we're working on the collider component. Now, the collider has to know about both particle accelerator beams, right? So we think we know what we're doing. So we go ahead and inject the Beam1 facade and the Beam2 facade. And we're going to get super clever, and we're going to have an observable for Beam1 status, an observable for Beam2 status, and everything's good to go, right? And then, of course, you get that knock on your cubicle, and your boss comes by, and your boss is like, hey, buddy, can you just make one small change? It's going to be super easy. And you're like, all right, yeah, sure, I guess. And your boss is like, you know, it actually would make more sense if we could turn on the beams from the collider component and not just from the individual beam components. And you're like, OK, that seems pretty easy. I've already got both the facades here, so I think all I need to do is just slap in a new turn-on beams function, call the turn-on function of Beam1 and the turn-on function of Beam2, and everything's good to go, right? Like, that's, boom, done, problem solved. And there's a small problem with this, though, because we're actually reusing those actions. If we think about this, if somebody runs that turn-on beams function from the collider component, and some problem arises, and they go back and look at the log, this is a lie. This didn't actually happen. Those actions, we have no idea whether those actions came from the beams or from the collider components. And that's a big problem. That defeats a lot of the purpose of NgRx. So another problem is if we look at this a little carefully, this looks suspiciously like reusing things as services, which again kind of defeats the purpose of the indirection of the NgRx architecture and the Redux pattern. We're basically reusing pieces of state as services, and that's not really what we want. So if we were doing this without NgRx, or without facades, not without NgRx, if we were doing this with plain old NgRx, what would we do here? We would normally just create a specific action for this situation, right? We would have a collider action type of start beams, And that's what we would dispatch to the store. And then from there, we would have an effect, and this effect would listen for that start beam's action and probably call out to some API, some fancy CERN API that turns on the beams, right? And then we'd have our reducer, and the reducer would listen for that start beams action, and the reducer would update the state in the UI. And then, instead of seeing something like this on the log with two different action types here, we would see one action type, and we'd have the collider namespace, and we'd know that we were starting both those beams, and we'd know exactly what was happening here. And in doing this, we're letting effects and reducers manage state, and that's what we want, right? So if we still want to use facades, if somebody out there is like, no, we still want to use facades, we can still do this, right? But if we go back to our facade here, the main issue with this is this turn on function, because what we've done is abstract away actions. And this is the dangerous part. So what we need to do is instead just have a generic dispatch function on the facade. And that way, the components will just dispatch the action through the facade to the store. And now we're using facades, but we haven't defeated the purpose of the NgRx architecture. Now remember, we had a little bit of a problem with the way this is set up, because it's sort of suspiciously like using service architecture again. So what are we going to do about that? Well, there's another thing that we can refactor that'll make this a little bit more obvious. So if you remember, we were using various selectors in our facades, and we were being really clever about it. We had our collider component, and we had the Beam1 status and the Beam2 status. Everything seems great with that. But then your boss comes by again. Hey, buddy. It's always that. It's always got to be, hey, buddy, right? Like, hey, pal, right? I just have one more thing that I need you to do. Just like super easy, real quick, no big deal. But it turns out that we actually want to know the status of both beams before we can turn on the Large Hadron Collider. So we need a Boolean that's a combination of the two beams, because we only want it to return true if both the beams are on. So you're like, all right, well, this is easy, right? I've already got the two facades. I've already got the two selectors. So I'm just going to do something super easy, slap in a new observable. I'm going to use combine latest, and I've got my two beam statuses, and I've got a map function that's just going to return a Boolean of the combined ones. Easy, right? Done. But there's another problem here. We've actually just introduced a performance bug by doing this. And it's subtle, and it's not obvious. But if we look at combine latest, where we pass in the two observables, and then we have this mapping function, that mapping function is going to run more times than you think it will. So let's look at the marble diagram of combine latest. So with combine latest, the top observable is going to emit A. The second observable is going to emit 1, and as soon as it does, combine latest will emit A1. And then when the top observable emits B, combine latest will emit B1, and then when the second observable emits 2, combine latest will emit B2. So that combine latest runs anytime there's a value for either of them. So there's actually an extra instance of that mapping function that's going to run. So that mapping function is going to run more often than you want it to, which is going to cause some performance problems, because you don't actually need it to run anytime either value changes. So how do we fix this but still use facades? Well, I've got really good news for you, because the NgRx team already thought of this, and that's what create selector is for. So with create selector, we can actually compose together selectors to compose together pieces of state that we want to keep track of. So we can use select Beam1 status and select Beam2 status, our selectors that we created before, and we can use our mapping function to return a Boolean value of the combined values. And now we don't have any performance problems. So now if we go back and we think about our service architecture versus NgRx Redux architecture, it becomes a little bit more clear, because what we should have done is had a specific collider facade. And this collider facade would keep track of everything that only the collider needs. So we'd have our store injected in the constructor, and we'd have our dispatch action that we covered earlier in the talk. And this time we'd have our combined status observable. That's the selector that we've created to compose together those pieces of state without messing with our performance. And then if we needed other selectors, like we needed to keep track of the magnet status or the magnet temperature or something, we could add that to the collider facade. That's no big deal. Or we could just keep it the way it is. But now we're using facades in a way that doesn't sacrifice the power or the performance of NgRx. So back in our collider component, we would use the collider facade in the constructor, and we'd have our turn on beams function that we can dispatch that unique action of turn beams on. And then we can use that combined status observable off the facade. And now we're using the facades in a way that works with NgRx just fine. So facades can make your life easier, which is awesome, but there's a little bit of nuance to how they're used in order to use them correctly. Because the thing to keep in mind is that the power of NgRx actually lies in the architecture. So we go back and look at our NgRx diagram again, our famous or infamous NgRx diagram, where we have components, effects, and reducers. We want to make sure that we're changing state with actions that are unique. We want the components to dispatch those actions and have them route through the effects and reducers to change state. And then we use our selectors to read state from the store. So it is possible to use NgRx with facades by inserting a layer of abstraction between the store and the components, but we have to do so in a little bit of a nuanced way. And this reminds me of something that one of my favorite teachers in computer science, Sandy Metz, says, which is to prefer duplication over the wrong abstraction. So it's really easy when you're getting started with NgRx to get a little overwhelmed with perhaps the boilerplate. Sorry, Brandon. It feels like you're writing a lot of code at first. And this facades pattern kind of seems like a welcome relief from doing that. So it's really tempting to jump to facades really quickly. But if you do it too quickly, you're actually choosing the wrong abstraction if you implement it naively. Kent Dodds has another way of saying this, which is avoid hasty abstractions. So you really want to think through the architecture decision before you just naively implement facades, though it is possible to do so in a way that's still compliant with NgRx performance and power. So the issue here is that it's sort of like you've spent all this time to craft this beautiful staircase of NgRx architecture, and then you sort of decide, like, you know what, up at the top, I'm just going to like jump through a hole in the floor in order to get back down instead of going down the staircase. So to conclude, I'm going to use the voice of reason himself, Brandon. Oh, no, that's in a minute, sorry. To conclude, if you're going to use facades, first and foremost, don't abstract away your actions. And secondly, make sure that you use create selector to compose your state and don't try to hand roll your own observables. And now I'm going to refer to Brandon Roberts and say, if you're learning NgRx to manage state, don't jump to facades too quickly because you're going to lose a bunch of time. So first and foremost, learn how the machine, the underlying machinery of NgRx architecture works, and then smartly implement facades from there. So you can find the slides as well as an article I wrote for the Auth0 blog on facades. It has its own sample code and all of that. And also, of course, you can always feel free to either come up to me, ask me questions about NgRx or authentication or upgrading or llamas or chickens. And that's basically it. So thank you so much for your time, and I hope you have a wonderful rest of your day.